Okay, I think everybody should be here now, and I welcome you to this webinar about interactive graph editing. My name is Benjamin Niedermann. I'm a software developer at Yworks, and I'm happy to welcome you to the 9th episode of this series about the art of graph visualization. In this series, I show you how to create not only beautiful, but also meaningful and useful graph visualizations. And with this, I mean graph visualizations that you can use to derive new information from your connected data. In the very first 5 episodes of this series, I gave a broad overview on important aspects that you need to take into account when creating such graph visualizations. This included, for example, layout, styling, animation, but also interaction techniques. Then in the other episodes subsequently, I showed how to do this programmatically, focusing each time on one of these aspects. And today I again would like to do this, focusing on interactive graph editing and giving you concrete examples how to do this on an implementation level. So taking the programmatic perspective and creating an actual application with this. And to that end, I would like to use Y-Files, so the main product of Yworks and diagramming SDK. And as a tool, I would like to use our playground, which runs with Y-Files HTML. But if you come from another platform, let's say from C# or you are using Java, this is no problem. The API is very similar so that you can easily understand and transfer the ideas from this webinar to your problems. So first of all, I would like to show you the playground as a tool so that you can understand how to use this playground, and all of the examples that I will show during the webinar you can also access in this playground. So let's go to the playground. One moment. And the playground consists basically of 2 main components, namely the component on the left-hand side containing the actual code that you can write here in the playground. And then on the right-hand side, you have a canvas where the graph visualization is drawn. So if I press run here, basically this code here is executed and this graph visualization is created. The idea is that you are given 2 global objects, namely a graph object that you can see here, and you can manipulate this graph object. So for example, by creating single nodes, but by also creating edges and also adding labels, for example. And then what you can do is you can use the second global object, namely the graph component, to actually draw this graph. And here the idea is that this graph component represents this drawing area on the right-hand side. And here what we do is we just call the graph component with morph layout and tell the graph component, okay, it should draw the graph using a tree layout. And as we have created the graph before as a tree, we actually get a tree layout that looks like this, where we have actually show this tree structure. One remark at this point, the graph component already knows the graph object. This is done in the background when using Y-Files, not in the playground. You can also specify which graph of the should be used for the graph component. So this is a very small example how to use this playground. If you're interested in more complicated examples or in other use cases, you can also go here to the examples menu, and here you can find a lot of other examples. In this webinar, I will also give you some links for the playground to directly get to the examples that I show you. So let's go back to the presentation. And so in the previous episodes, I always used a running example, and I would like to reuse this example again. In this webinar, it's about a music database, which is called Discogs, and it's basically a Wikipedia-like database with a lot of entries about audio recordings and about artists. So thousands of users maintain this database, and it already contains millions of entries. And the nice thing is that you can easily extract the data and build up a graph structure on this and can play around with this, just finding out how to create graph visualizations. And in the previous webinars, I focused on the idea that we try to visualize this data. So I showed you different examples how to visualize this data, for example, focusing on layouts, but also on the styling. Today, I would like to take a bit different direction on this. Today, I would like to present you how to create a small editor. And the idea or the scenario is that this editor you could use to actually manipulate the database so that the user could create this graph visualization interactively and then derive from this new entries for the database. So let's have a look how this editor should look like. You can also go to this link here. Let's go to the playground. So on the left-hand side, again, you can find the entire code. I have divided this into some sub-regions that you can expand, and you can see the entire code. But during the webinar, I will explain this block step by step. So for the moment, I'm not interested in the code, but only in the application itself. So let's talk about what we can do. So of course, what we would like to do is we would like to create some nodes, maybe some nodes representing artists, but maybe we want also to create nodes representing music groups like this. And of course, what we also would like to do is to create some edges. And then when the edges are created, some labels should also be created. Of course, it would be nice to apply some automatic layout by just clicking on a button, and then maybe also editing the graph visualization would be nice. So for example, changing the label and reacting on the change of the label. So let's say that we have here Paul McCartney. And then in the background, I'd query some database to get the image, and then the node is exchanged. Besides that, it would be also nice if we have some typical editor functionality like snapping. So if I move this node here around, then we get these snapping lines telling me where it would be good to place this node. Also, I have here some kind of grid snapping. So these are the ideas that I would like to present in today's webinar, and I will do this step by step. The structure of the webinar will be as follows. First of all, I will talk about the basics, so how to set up such an editor in WI files. And then I will talk about how to create and modify graph items in this editor. And then after that, I will talk about more specialized things like snapping, but also how to customize the clipboard. And then at the end, I will also give an outlook to other topics that I haven't covered in this webinar. So let's start with the basics. So the idea is that the graph component that you have seen before in the playground is basically the main object that controls the canvas. And then this graph component has also some kind of input mode, which handles the events, so the user events. So, and in WI files, you can find two major input modes, namely the graph viewer input mode and the graph editor input mode. And both are basically event handlers that you can configure and which you can use to react on user interactions. So the graph viewer input mode is for viewer-centric applications. One example that I've also shown in the previous webinar is, for example, here this Wonderlands demo. So I can just go here. And the idea is that we can explore the data and then we can also extend the graph visualization. But basically, the graph visualization or the data behind that is already given. We just expand the graph visualization, but it's not like a really editing of the graph visualization. It's more like only viewing the data. So this is what I've shown also in the previous episode. And then today I would like to focus on the editor-centric application. So a typical example for this would be iAdLive, where you actually can create entire graph visualization. So here you have already some small example. You can drop in some nodes and you can just create edges and so on. And basically, the entire Wired application is also built on WI files. So if you're interested in the viewer input mode, then I recommend you the episode episode 8. And today it will be about the graph editor input mode. So the graph editor input mode is a really large class basically in WI files that has a lot of members. So one part are operations or members that allow you to enable operations that the user can do. So for example, you have here these properties about creating edges or creating nodes. And what you can do is you can say, okay, if I want to use the graph editor input mode and I would like to allow creating edges, but I don't want to allow creating nodes. So you can really customize this for your use case. Further, as this input mode is already large, we also have introduced child input modes that are specialized for some certain use cases and interactions. So for example, when an edge is created, there's a special child input mode that is responsible for this. And there are several input modes that handle different use cases. Apart from that, there are also a lot of events that you can react on. So you can register your listeners and then you can react on the corresponding events. So for example, here you have such events like some kind of click events, but later on you will see also events where we react on creating edges or creating nodes. Depending on the events, they are either located directly on the graph editor input mode or in one of the child input modes. Sometimes it's also useful to get some kind of feeling about the events when they are triggered. Of course, you can read this also in the documentation, but we also have some kind of demo that you can use for this purpose. So if I go there. You have here this demo, and what you can see is that you can say on which kind of events we would like to react. So for example, I could say, okay, if an edge is created, I would like to see this. And now when I create this edge, what you can see on the right-hand side, that is that there are already a lot of different mouse events, but when I release this edge here, for example, then I also get this edge created event. And this is really helpful sometimes to see how these events are fired in WI files. So now I have explained a bit how to use or what possibilities you have to use the graph editor input mode, but now I would like to show how to use it actually. And it's quite simple setting up the graph editor input mode. So basically what you need to do is just creating one and then configuring it. Here, for example, I've used the orthogonal edge editing context, which basically is the idea that when creating an edge, the edge is not arbitrarily drawn, but you only can use horizontal and vertical segments. I can show this here in this video. So when placing or routing or drawing this edge, you can only draw orthogonal edges using some bands. Apart from that, what you also can do is to configure this further, this graph editor input mode. So for example, you can set some defaults for the styles that are used when creating edges. Here in this case, I use an a stroke with 4 pixels and the current color. This current color is a special thing also in the playground. And then I also say, okay, I would like to use the CSS class edge style. And so let's have a look at this, how to use this then actually in the playground. So here's the code that I've just shown you before. I've created this object, and then I also define some default or values. But what I also need to do is to register this input mode. And for to that end, you can use this property input mode of the graph component and just tell the graph component, okay, use this input mode. And with this, you already have a lot of functionality. So when I click here, for example, I can create these nodes, and I can also move them around. I can resize them. And as I said, you can also configure this, whether this is allowed or not. Further, I can also draw here some edges. In this case, I can only draw orthogonal edges. So this already is the basic setup for the graph editor input mode. So let's talk about how to create graph elements and modify graph elements. And I would like to start with the node elements. So there's this property on the graph editor input mode that says allow create nodes. And by default, this is set to true. And in our use case, we also want to have this. And the idea is now that we would like to have 2 types of nodes, and so that we can create nodes for the artists, but also nodes for the music groups. And we need to tell this somehow the graph editor input mode. So how to do this? One possibility is that we use the node creator of the graph input mode, which I will show in a few seconds. So here's the first of all some setup. So what I do is I define a mode, and this mode is either an artist or the music group, and by default it's the artist. And then the playground has the possibility to add some toolbar buttons. This is a special thing for the playground. You can react here on any kind of button, of course. And the idea is that we tell the button here at this in this lambda function how to change the mode. So basically, if we have a music group, we change the mode to artist, and otherwise we change the mode to music group again. And we use this information then when creating a node. And here to that end, the graph editor input mode has the property node creator, and this also expects a lambda function. And the idea is that this is always called when a node should be created. And then this function is responsible for creating the actual node. So what we do here is we call the graph and tell the graph, okay, it should create a node, and this node is returned. And what we also do is we configure this node. So this function also gives us the location where the node should be created. So basically the center location, or the location of the mouse click. And then we also get the graph, and sometimes if you have some grouping, it also tells you whether it should have a parent node, this node. So what I do here is, okay, I say, okay, the parent becomes the parent, the layout of the node, so the shape or the size of the node should have the node default size, and the location should be just the location of the mouse click. And then if you go to the playground, I can show you this in a second. I also have here this predefined array of styles. And for each of these modes, I have defined an own style. And I just request this style here. And then the node also gets a tag. The tag is just an additional information. It can be defined arbitrarily, and it's helpful for creating the logical flow in your application. And then we also add some labels. Also defining some label position, which is predefined in the, or which I have predefined in the playground. And then at the end, I also would like to have some ports at my node where I can actually add some edge. So how does it look like in the playground? We have here these regions, and in this region basic definitions, you can find these node styles, as I said. And here I have defined for the artist an image node style, but also for the music group, I have defined an image node style. And here I've also defined some label positions. And then here, when creating the nodes, I actually apply the code that I've just shown on the slides. So this is basically all what you need to do. And when executing this, I can click here, and now I can go to this button here, mode, and then I can also change the type of node. Next, what I would like to show is how to create edges such that I can only connect music groups with artists, but not with other music groups. So for example, here I cannot leave or say that the edge should end at another music group, but it needs to end at an artist. And now I would like to show how to do this. And to that end, I would like to show the create edge input mode. And here I would like to start with a bit easier example, namely about how to reacting on edge creations. And as you have seen, there's this property node creator. There is also the property edge creator on this child input mode, but there are also events that you can use to react on edge creation. So for example, here's this event edge created, and it's always called when the edge is created. And the idea is now that we just react on such an event, and to that we can register listener to our child input mode on this event, and then we can react. So for example, we can say, okay, we would like to customize our edge. The edge is automatically created in the background. We don't need to think about this, but we just want to customize this, for example, by adding a label. So this is also shown here in this example. So if I create two nodes, I need to create another node of another type. And now when I release the mouse button, the edge is actually created, and then also the label is created because we react on the listener. So now I really want to show you the example that I've talked before. So I would like to manage that I can only create edges between artist nodes and music group nodes, but not between music groups nodes and music group nodes. To that end, I think I've just skipped a slide, namely this. To that end, there is the interface iPort candidate provider that we can implement. And the idea is that we tell the graph editor input mode which ports it can use to connect the new edge to. And so what we need to do is we need to define the ports for the beginning of the edge, so for the source of the edge. And we also need to define port candidates for the end of the edge, so for the target of the edge. And then what we basically do is that we say, okay, that we don't create any candidates for music group nodes when the edge starts at a music group node. And if it starts at an artist node, we don't create any ports for other artists nodes for the target. So this is the basic example idea. So what we can do is we can implement this interface. We don't need to implement the entire interface, but we can use an base class which already implements this interface and just specialize some of the important functions or methods. So first of all, what I expect is that I get the node from which the new edge should start. So let's assume this is an artist node. And now I would like to create candidates where the edge actually can start at this artist node. To that end, I can override this method getPortCandidates. And basically what it does, it fills this list here of iPort candidates with the existing ports that are already existing at the artist node. And then it returns these candidates, and the graph editor input mode will use these port candidates for possible starting points of this edge. Then what I also want to do is to define the target ports of this edge. And here, basically, the logic comes in where we say, okay, we can only connect to music groups, and assuming that the given node is an artist node. So what we do is we get this source candidate, and then we also go to the we go basically. No, I think I have. I'm sorry. I think I have mixed up this a bit. The idea is that the owner is the actual node where we want to end the edge. So here the idea is that we have an edge and we would like to decide where it should end. The source node is, so for example, the artist node, and then the end is here in our example, maybe the music node. And then we need to decide whether this is whether we can create valid or invalid ports. Sorry for this confusion. So here the idea is, let's make it concrete. The owner is a music group. And the question is, can we end our edge at this music group? So what we need to decide is whether this source node is an also music group or an artist group, node. So what we do is we just take the tag of the node. This is what I've added before to the node. So the information, whether it's a music group or an artist node. And then if the tag is different to the actual port tag of my owner, then I know this is a valid port, and otherwise it's an invalid port. So if both nodes have the same type. So this is basically the idea of this port candidate provider. So let's go to the playground. I just want to show this again. So I have here two artist nodes and a music group nodes. And what I can do is I can start here this edge. When starting this edge, this method is this getPortCandidates is called. And now when I go here, for example, to the artists here at this point, the getTarget port candidates method is called, but on the node I'm currently hovering over. And then I decide whether the source node has the same type as the target node. And if this is the case, the port is invalid, and otherwise it's valid, and I can actually release the edge and create this edge. What I haven't said before is how to register this actual port provider. And here you can see the entire code for this. This is basically this part here, the class that I've presented before. And then what I need to do is I need to register this. And registering is here done using so-called node decorators, which is an important and a powerful tool, as you will see in a moment. So what I do here is basically that here you can tell the graph that it should use for each node an own tag port or different tag port candidate provider, specifying here this lambda function. So let's go back to the slides. So here again, I show you how to register this. And this is a very typical pattern that you can find in WAV files, that you use these kind of decorators for specifying or for customizing the behavior of graph elements. So basically the idea is that using this decorator, each node in the graph gets a different tag port candidate provider assigned, and this is called for these kind of interactions that I've shown you. Another example is, for example, to restrict the node sizes. What you can do is that you can call register and decorator, and for the property size constraint provider decorator, and here you can register a node size constraint provider, and with this you can restrict the node sizes so that the user can only create nodes between 20 pixel width and height and 200 pixels width and height. And there are many different kinds of decorators that you can actually use to customize the behavior of the graph elements. Maybe you already have recognized I've used here different methods for this. I've used the set factory here at this point, and here the set implementation. So here the idea is that each node gets an own instance, which is important. Here the tag provider, the port candidate provider, is defined for each node differently. But what you can also do is you can just define the same instance for all of the nodes. Here the idea is that all of the nodes get the very same instance of the node size constraint provider. So what we also can do in this very small editor, we can reconnect edges. I just want to show you this small video here. So we can reconnect this, and here again, it's important that we can only reconnect the nodes that the edge such that it ends again at an artist node when it starts at a music node, so that it does not become inconsistent. And what we can do is a very similar approach that I would like to show you now. Oops. So again, what we do is we need to implement some kind of interface. This time I don't use a base class, but I directly implement this interface. It's called iEdge Reconnection Port Candidate Provider, and it works similarly. So it provides port candidates for the nodes when reconnecting the edge. So I need to decide which ports are possible for this reconnection. In WAV files, when using the class framework and implementing such interfaces, you typically do this via this class called base class. So you extend this base class, and as an argument, it gets the interface that you would like to implement. Again, I just store the edge that is created with this, or that is used for this, or for which we create this candidate provider. And what we now need to do is we need to define the source port candidates, and also then later on the target port candidates. So assume that the user would takes the edge at the source and want to change the source of the edge. Then this method is called. And here the idea is that we just go through all ports of the graph and filter all ports that are not allowed for reconnecting. And they are not allowed if they we only take these ports that are allowed for reconnecting. So we remove all other ports that are not allowed. So the ports that are allowed are those where the tag is the very same as the source tag of the owner. And for them, we create a default port candidate. So this is a simple object that you can use to wrap this port in order to get a port candidate. The very same we do for the target port candidates. Here we go through all ports of the graph and we take all ports that have the very same tag as the target node of our owner edge. And this, for these ports, we create default port candidates. And then again, we need to register this, and we again do this using the decorators of the graph elements this time, but for the edges and not for the nodes. So here you have this region handling reconnecting edges, and here you have this class that we've just implemented. And then at the end, we also have here this registering of the reconnecting port candidate provider. As this should be an object defined for each edge, we need to use the setFactory method. And we say, okay, we create for each edge such a candidate provider. And this time we have this edge decorator instead of the node decorator. And this edge decorator has this property edge reconnection port candidate provider decorator. And with this, you get the desired behavior. So let's have a look at this. I have different nodes, let's say like this. And I connect this edge to this node. And I, for example, take the target of the edge. So I cannot let the edge end at an artist, but only at a music group. And this is all what you need to do in order to get such an behavior. So this is what I've shown in the playground. And the last thing that I would like to show for this part is how to react on label changes. And this is quite easy. We just need to register some listener to the label. In this case, we have some label text changed, but you can also directly react on the editing process. So there's different kinds of example, possibilities to do this. So in our example, we just use this to to query a lookup to get an image for the label text and then replace the placeholder image with the actual image. The code is quite easy. We have an add label text changed listener. We register here this listener. This listener has an event, and this event has an item, which is a label, iLabel, and then we just have a look at our image lookup, which I've created at some other point, whether this label exists in this lookup. And if this is the case, I just create a new image node style using the URL within this image lookup. And that's all what I need to do. So let's have a look at this. So here we act on label editing. And what I can show you, for example, this image lookup is basically here a very simple lookup where I have for some names, some images. So let's have a look at this. I create an artist node. I can go here. I can write Paul McCartney. And when I press enter, this event is called and I can change my graph visualization. So what I now would like to talk about is applying layouts. This should be only a very short part of this webinar because there are other episodes that you can watch for this. The idea is that I would like to trigger a new layout or trigger a layout algorithm in order to get an automatic layout. And again, what I do is I just create a toolbar button layout and I react on this. And what I do is I call the graph component using morph layout. And in this case, I use an hierarchic layout and I use a very basic configuration. You can use here much more complex configurations in order to create your graph visualizations. there's also an example in the playground, but I would like to skip this as this is basically discussed in these two episodes. So I recommend you to have a look at both episodes. So let's go to the next part. First of all, I would like to also mention related demos. First of all, especially the demos give you some kind of source code that you can also use for your use cases and adapt for your use cases. So for example, I just picked here the interactive hierarchic layout, which is also a kind of an editor input mode, which is used, but it reacts incrementally on your changes, applying the hierarchic layout incrementally. Then there's also a demo about business process model networks. Here again, it's a very similar example where you can change the graph and can do more complex things like tracking in these elements and then creating new edges. And then again, running the layout. So it's a very similar example, a bit more complicated. And if you are interested in the source code, you can also go to GitHub and find the source code here. If you're really interested in what you can also can do with the graph input mode to get some really nice impressions about this, you can also have a look at the Wired-Live, which is a fully developed editor for web browsers, and there you can really see what you can do actually with this graph editor input mode. So let's go to the next part, namely snapping. So here the idea is that we say, okay, we have these graph elements which can be moved around by the user, but it would be nice if the user gets some help when moving these elements, having these typical snapping lines. And just to show you a few of these types of snappings that we offer is I want to give you here some examples. So for example, we can snap elements on the center, but also on the border of the elements. We can also introduce hints about same sizes so that the user knows, okay, when resizing the node, that it now has the same size, for example, as or the same width as this node. Also, when moving a node, sometimes it's good to equally to have equally distanced nodes. So then you get this kind of visualization and also kind of snapping. But sometimes it's also nice to have some global grid where you can place the nodes on. And yeah, I would shortly show how to configure this and then also to customize this or to create a grid snapping. And so let's have a look at this. It's quite easy. Basically, what you can do is you just need to create a graph snap context, and then you just need to tell the graph editor input mode to use this snap context. And with this, you already get the snapping functionality. So if I go to this playground part and run this, so I have these two nodes here, and I already get these snapping lines that I've talked before without doing much or without writing a lot of code. It already comes with the library. Very similar, this is for grid snapping. For grid snapping, you only need to define basically your grid, and then you need to register your grid using the snap context object that you have seen before. And here you can also tell which of the graph elements actually should snap to the grid. Here, for example, the nodes and the bands. And then you can also tell a type of grid snapping that you would like to use. In this case, just the grid points. And doing this, there will be no visualization actually for this grid. but you also need to create some kind of visualization, or you would like to do this so that the user can see the grid. And this can be done using the Grid Visual Creator, so you don't need to draw the grid on your own, but you can reuse already existing components. And then you just need to register this grid in the graph component using the background group, so which is responsible for drawing the background. And then you basically get here this behavior that this node is snapped to the grid. So this is actually all what I wanted to show you. For grid snapping, there's much more what you can actually do. You can customize your snapping. So if you go to our demos page, you can find also, again, several demos about this, about the basic things that I've just shown you, but also about customizing snapping, where you can see here, okay, we have some kind of possibilities to also define other snapping points. And if you want to learn more about this, I would like to refer you to the demos. So I would like to go now to the part about the clipboard. So the clipboard at the beginning sounds quite obvious, but if you think about how to copy parts of a graph, this becomes a bit more complicated actually. So the idea is actually really that the user has the possibility to mark some elements and then just to copy the elements, so that also some other elements, sub-elements are copied with this element. So in this case, I've just marked the nodes 6 and 7, and then I copied this, and the labels are, for example, also copied. So when thinking about clipboards and copying graph elements, you need to think about how to copy them. And what you can do is you can classify these elements, namely in independent elements, so items that can exist alone, for example, nodes, and dependent elements, so items that cannot exist alone, so for example, edges, labels, bands, and boards. So assume I just delete this node, then the edge would end in at no node, so it cannot exist. So when, for example, deleting the node or copying the node, I need to think about what to do with the dependent elements, or especially when copying dependent elements, what should I do with the independent elements? So how can I make sure that I get a consistent graph structure again? And basically, there are different cases how the clipboard works, and I just want to show you a few examples. So here in this example, I have marked this node C, and this is the selection before copying. So I copy now the element, I mark another element, and I paste this element. So I've not only marked the node C, but also the edge. And then what I get is that the element C is automatically attached to element A. So this means that for the dependent element, I've decided, okay, it should connect automatically to A. Then about copying, another scenario of copying. Here in this case, I just select these two elements, but I don't select any other elements, which basically then means that I say, okay, I would like to copy this independent element, and for the dependent element, I just leave the other side as is. So I just copy this information, and then I get an edge from B to C automatically. And then there are different ways also for copying dependent elements. So here, for example, I copy this dependent element, and I can select two other elements, and when pasting it, we can automatically derive from this information, okay, you obviously want to have a connection between these two nodes, copying this element. This is important to have in mind when thinking about graph editors and copying and pasting elements, so that you know how this editor actually behaves. Of course, you can also customize this copying process. So what you can do, you can create some constraints, for example, how elements can be copied. And I've used a very simple example to illustrate this. So the idea is that only nodes of the active mode can be copied. So if I say, okay, I currently want to create artist nodes, I can only copy artist nodes. This example here also shows this. I create these music groups and these artist groups, and I mark all of these nodes and I copy them, but when pasting them, I only get the artist nodes. This is a quite simple operation, but it should show you how to actually do this or how to actually customize this clipboard. And to that end, I would like to show you the source code. So what I do is I implement an interface which is called iClipboard-helper, and this can be used to customize your clipboard. And then what I do is I create, or I call this the restricted clipboard, and then I need to implement some functions or methods. And here I have these methods that are called when actually doing this copying. For this, I just use a simple implementation that basically says, okay, we don't want to do nothing. We don't want to do anything, but we want to override or implement methods that are called before copying. So where we can say, okay, this element can be copied or not. And here, for example, we have this method should copy. It's called on a model item, so on a graph item. We check if it's an inode. If it's not an inode, then it can be copied. We don't care about this. Or it's an inode. In this case, it should have the same tag as the current mode. And then we can copy it. And we can also do this for the cut operation, and pasting can always be done. This is basically all what you need to do. And again, you need to register this class in this entire process. And this is done as follows. Here you have this class here, and again, what you can see here is we are again using the node decorator, and this time we use the property clipboard helper decorator. And we don't want to create for each node an own clipboard helper, but we want to reuse the clipboard helper for all of the nodes. So we use the set implementation using one instance. And with this, we get the desired behavior. So again, there are many different demos that you can have a look at. I picked just 3 of them. So for example, here the clipboard, the deferred cut clipboard and the graph copy, you can find them on our demos page. I just want to show you here a very nice use case for customizing this clipboard. Often that when copying elements in drawing editors, they are just grayed out a bit when cutted. When they are cut, so that the user can still see them, but knows, okay, I've cut them. So in pressing Control X, these nodes are cut out, but I can still see them, and now I can paste them somewhere else. So it pastes at the same position. Also, that you can customize. And then I get the normal visualization. And this demo shows how to do this. This is a bit more complex customization, but basically use similar techniques as I've shown before. Yeah, and this should give you already some ideas how to customize the clipboard. And of course, I could only give you a very small overview on things that you can do in this graph editor input mode. There are many more things like drag and drop. I've already shown you some demo about this. Or also using folding, where you have folder nodes that you can expand and collapse. And this you can also integrate in your editing process. Using context menus and things like lasso selection, but also changing the cursors. And again, also these 5 examples are only few examples that you actually can do. And then if you are interested in more and also in how to implement this, I really recommend you to go to the demos. And with this, I would like to wrap up the main part of the webinar. If you have some questions, now it's the time to place them in the chat, and I will try to answer them in our Q&A session. Oops, it's yeah, in our Q&A sessions. So I will have a look at the chat, and I will see whether there are some questions. So is it possible to display the snapping lines across swim lanes so that to see snapping lines between nodes of different group nodes, and to be more precise, you use a table class as swim lane, not just a restyled group node? And the answer is yes, you can actually use this. Actually, the default snap lines go through other nodes within a certain range. And the nodes can be also group nodes, table nodes, and then normal nodes. So the snap lines are basically independent or the snap lines consider the bounds of the nodes independently from the types of the snap line. So I have a question about edges. Is it possible to restrict the direction of the edges? For example, can we ensure that the starting edge is always on the left side of the node and the end edge is on the right side? So basically, if you talk about automatic layouts, so when you really want to automatically lay out your graph, you can do this using, for example, port constraints or port candidates, where you can specify this for your nodes. You can specify this for individual nodes, but also for all nodes, where the edges should start and end. And for the other, probably which you also want to know, is whether this can be also done outside of an automatic layout. And for this, what you can do is you can define these port candidates, as I've shown in the webinar, for the particular sites where the node should end or start, where the edge should start or end. So if the edge should start only on the left-hand side, then you can say, okay, I register a port candidate provider that only creates port candidates on the left-hand side of the node. I would like to know how we can create or how we can restrict layout algorithms to connect edges to a specific side of the nodes, for example, side north. As I said before, you can do this basically using port constraints. So you can configure your layout algorithms that it considers port constraints for nodes. And basically what you can do is via the corresponding layout data, you can define such that, for example, the edge should only start or end at the north side of the node. There are also demos on this that you can have a look at, or also in our developer's guide. When looking for port constraints, you will find articles about this, how to do this in the concrete case. The next question is whether you can have the link for the demos I've shown. In the webinar. So what we can do is, of course, we can also in the following up email write you these links. You can also go just to our demos page, yfiles.com/demos, where you can also find all these demos. But for the particular demos, we will send you them in the follow-up email. And I just reached here, a colleague of mine says, okay, we also provide these links in our YouTube channel. There you will also find these links. Okay, I think there are no questions furthermore. And with this, I want to thank you for your attention, and I wish you happy diagramming.